Hi, I'm Bruce Jameson, here to talk about some work done by Alec van Herwengen finishing around 2004. He worked on fracture character in compression tests. To do the compression test, you isolated a column of snow about 30 centimeters across and 30 centimeters up along the slope. Place a shovel on top. Apply 10 easy taps with the fingertips moving from the wrist, 10 moderate taps moving from the elbow, and then 10 hard taps swinging from the shoulder. When a fracture occurs in the column, we note the number of taps required to cause the fracture, we note the depth of the weak layer, and some details about the weak layer. The key idea in this video is if we observe the character of the fracture, what does it look like at the instant of fracture? Does that help us say whether skier triggering is likely on the adjacent slopes? Now, let's suppose we had a perfect instability test. When we did the test and applied a low force to get a fracture, if every time we got that result, we skier triggered the adjacent slope. In other words, we had 100% skier triggering whenever we had applied a low force to get a fracture. Whenever we applied a hard force to get a fracture, we got 0% skier triggering. And then perhaps for some moderate force applied, we would see some intermediate value of skier triggering. That would be an ideal or a perfect instability test. Here are the real results obtained for the compression test. Here's the frequency of skier triggering over here. We have a bar for the first 6 easy taps, then a bar for the next 3 easy taps and the first 3 moderate taps, all the way and up through until we have the last 6 hard taps. We see the most frequent skier triggering here for the easies, moderates, and the least frequent skier triggering for hard taps, but it doesn't drop off nearly as much as we would like. For the last 6 taps, we see about 18% of the adjacent slopes being skier triggered. These could be considered false stables because we've applied a lot of force, we're on our last 6 taps, and we are seeing an indication of stability, and yet we're seeing 18% of the adjacent slopes being skier triggered. So now we're going to go through, see some videos and look at the results for each of these 5 kinds of fracture character. For sudden planar, or SP, or a pop, we have a planar fracture that suddenly crosses the column with one loading step, that's one specific tap, and then slides easily on the layer. We decide if it slides easily on the layer either by gripping the sides of the column and seeing if it slides easily on the fracture, or if we're on a steep enough slope, if the upper part of the block slides off. A thin planar fracture suddenly crosses a column and the block slides easily. This is an example of a sudden planar fracture. In this slow motion clip, we see a fracture that is sudden and planar. Here is another example of a sudden planar fracture in which the block slides easily. So sudden collapse, or SC, also called a drop, is when we get a fracture, it appears suddenly, and we see the upper part of the column, it sits down because the weak layer collapses. This is slope normal displacement, and it's visible as a collapse on the weak layer. Here, depth hoar at the base of the snowpack collapses. This compression test produced sudden collapses on 2 layers. Collapse, it's just under the crust. For sudden collapse fractures, the fracture surface is often not planar. So for the progressive compression, or PC kind of fracture, the fracture normally crosses the column with one tap, that is one loading step, and then when we do subsequent loading step, it squashes. So we have progressive squashing or compression of this rather thick weak layer. In this slow motion clip of a progressive compression fracture, the fracture crosses the column, and then we see step-by-step squashing of the thick weak layer. In this example of a progressive compression, the arrow points to a thinner weak layer that fractures and then progressively compresses. So resistant planar, or RP, means that when we're tapping on the top of the column, we see a fracture that either goes part way, we tap again, and it goes the rest of the way, or if it goes all the way in one single tap, when we grip the sides of the block, it doesn't slide easily, it drags. In this example of a resistant planar fracture, the fracture or crack does not cross the column in a single loading step. Near the top of this column,
there are two more RP fractures in which more than one tap is required to drive the crack across the column.
A break, or a B, is a non-planar or irregular fracture surface that takes place. So this example here is not planar.
Breaks are fractures that are either irregular or non-planar. This fracture is both non-planar and irregular.
So here again is our graph of the frequency of skier triggering without fracture character. So we're only looking at the number of taps across the bottom here, and it does drop off as the number of taps increases, but not nearly as much as we'd like. Let's see if fracture character improves upon this. So here inset is our graph of the frequency of skier triggering for the number of taps alone. Here's the results of Alec's study for fracture character. And for sudden planar or sudden collapse, we see quite a high frequency of skier triggering. For the other three kinds, break, resistant planar, and progressive compression, we see a much lower frequency of skier triggering. So fracture character is distinguishing between whether skier triggering is likely or unlikely, and it does so much better than by paying attention to the number of taps only. You're probably wondering about these numbers here above the bars. In this case here, we got 30 results with breaks, and only in one of those were we on a slope where we skier triggered the slope. So we still get some false stables in here, but it's much less than we did when we paid attention to the number of taps only. The other interesting thing is that most whoops, which happen on fairly gentle terrain, were most common when we had sudden collapse or SC fractures. So you're probably wondering, what if we combine the number of taps and the fracture character? Can we do an even better job of anticipating whether skier triggering is likely? So here we see the easy taps, the first 10 taps, and we see the most frequent skier triggering takes place for the sudden planar and the sudden collapse, and very low frequency for the other three kinds of fracture character. I'll move that graph for the easy taps up here, and now we're looking at moderate taps down through here. Again, we see the most frequent skier triggering occurs for sudden planar, sudden collapse, but we still have a few with the breaks, the resistant planar, and the progressive compression. For hard taps, the last 10 taps, we see all of the skier triggering we saw when we had hard taps were sudden planar or sudden collapse. So now we see in the easy range for the moderate taps and for the hard range, we see the most frequent skier triggering takes place for sudden planar and sudden collapse, sudden planar and sudden collapse, and sudden planar and sudden collapse. The other thing you'll notice is that as we go from easy to moderate to hard, the frequency of skier triggering drops off. And in Alec's study, which finished in 2004, we did not see any skier triggering in the hard range for progressive compression, resistant planar, or breaks. So, in summary, Alec identified 5 common types of fractures in compression tests. He showed that the fracture character is a valuable addition to the compression test score, but keep in mind that no single compression test or any point observation of the snowpack is a foolproof indicator of whether skier triggering is likely or not. We saw that sudden fractures, that is, sudden planar and sudden collapse fractures, had the highest frequency of skier triggering. After this study was complete, Alec went on to show that the snowpack characteristics for sudden planar and sudden collapse favor both the initiation of fractures and the propagation of fractures, and that's why we see the most frequent skier triggering beside sudden planar and sudden collapse fractures. So these are the good folks who paid the bills so we could go out and collect the data for fracture character and analyze the data, write the papers, and make presentations such as this one. Thank you.